Welcome to the Explainer. Today, we're going beyond what's known as the Trig wall to uncover a really fundamental flaw in modern computing. And more importantly, we're going to dive into a brilliant Zenodo research breakthrough that actually fixes it. We're going to pop the hood on the physical silicon that powers our entire world to see exactly why our machines struggle with undeniable truth and how a totally new mathematical framework is pretty much changing everything.
Okay, let's just dive right into this staggering reality from our sources, because it fundamentally challenges how we think about computers. The vast majority of the heavy computational lifting, the stuff powering massive AI models and complex decentralized finance, well, it isn't delivering exact mathematical truth. Instead, it's basically just relying on highly educated guesses. Get this, 80 to 90% of modern AI compute cycles are just hardware-level approximations. So this naturally leads us to a pretty big question. What actually happens to our most critical systems when they rely on a foundation of microscopic guesswork? Think about it. If you have tens of thousands of machines trying to reach a perfect consensus, or an AI agent trying to lock in a verifiable fact, building that on top of approximations is just a recipe for hallucinations, exploits, and ultimately totally shattered consensus. To really understand this crisis, we have to look down at the physical silicon itself and meet the main culprit here. We'll call it the FPU gambler. The floating point unit was originally designed for blinding speed, right? It's built to handle the infinite, messy, continuous numbers of the real physical universe. But to pull that off within limited memory, it acts like a frantic gambler. It literally sacrifices exact deterministic perfection by throwing probabilistic darts at a board, just rounding off decimals to save time. So what we have is this fundamental hardware battle going on inside your computer. On one side of your processor, you have the chaotic, dart-throwing FPU gambler making these lossy approximations. And on the exact opposite side, you have the arithmetic logic unit, or what we can call the ALU surveyor. The surveyor is strict. It uses exact discrete integer arithmetic where 1 plus 1 equals exactly 2 every single time. It achieves absolute universally verified truth without a shadow of a doubt. Now, the core obstacle keeping us trapped with the unpredictable gambler is what researchers call the Trig wall. This is a severe computational bottleneck. You see, when we try to calculate complex, continuous geometric curves, like the trigonometric circles used in AI vector orientation or DeFi market makers, the processors simply cannot handle it natively without guessing. It quite literally hits a wall. And the mechanics of this failure are actually written directly into the hardware via the IEEE 754 standard. That's the rulebook dictating how computers handle math. Because processors can't store infinite decimals, this standard forces the hardware to constantly chop off tiny fractions, like the 23rd decimal bit, for example. Over time, this creates these microscopic rounding errors. When you multiply that across billions of operations, it creates a non-deterministic drift. And that drift makes perfect agreement across different machines mathematically impossible. So the absolutely crucial point here is that this drift eventually hits a critical 50% line. This is a terrifying threshold identified in the research. It's the point where those FPU approximation errors compound so heavily over repeated tasks that the data just becomes statistically useless. The system literally crosses the line from minor inaccuracy right into total mathematical chaos. Researchers have a great name for this catastrophic loss of data provenance. They call it the wood chipper effect. Think of it like a giant blender. Once you toss your clean, pristine data in and chop it up with all these floating point approximations, you can never perfectly reverse engineer that smoothie back into the original ingredients. The exact historical trace of the data is permanently destroyed. There's no going back. But here is where the story completely shifts, thanks to a massive breakthrough published in recent Zenodo research focusing on 1-bit large language models. The stakes here are incredibly high. Why? Because the paper outlines a first principles algebraic framework that finally provides a way to completely shatter the trig wall and bypass that FPU gambler once and for all. The absolute key to this Zenodo research breakthrough is a brilliant concept called side normalization. It's basically an elegant algebraic loophole. By anchoring the coordinate system to the transversal constant where a strictly equals 1, we can actually transform messy trigonometric curves into straight lines. And by doing that, we entirely bypass those floating point approximations. To visualize this, think of it practically like a mathematical magic trick. By fixing that transverse component, it literally takes those complex, unpredictable trigonometric curves and pulls them taut into perfectly exact, completely predictable straight lines. We're no longer asking the computer to vaguely trace a circle, we're now snapping it onto a rigid, undeniable grid. And all of this builds into a brilliant three-step paradigm shift. First, as we said, we anchor the system to A equals 1. Second, we entirely swap out that power-hungry trigonometry for discrete reciprocal shifts. And third, we natively track all the mathematical leftovers via something called GRT. Now that third step, it is absolutely vital. Global Remainder Tracking, or GRT, ensures that the machine never ever throws away the mathematical spare change. Instead of rounding off a decimal and just deleting it into the void, GRT shifts the math along a rational lattice. Every single tiny fraction is accounted for natively. This guarantees 100% mathematical fidelity without a single guess. When we compare this new method to the legacy systems, the upgrade is undeniable. By replacing heavy cosine scoring, which totally relies on that FPU gambler and complex transcendental math, with discrete reciprocal shifts, we take the guessing completely out of the equation. We are officially kicking the gambler out of the room and handing the reins back to the exact, uncompromising ALU surveyor. And what's truly wild here is that the underlying engine powering these shifts actually relies on ancient math. It uses Pell's Diophantine equations and rational coordinate rings to map these straight lines onto a pixelated grid using only division-free whole numbers. It completely replaces vulnerable square roots with simple Brahmagupta group products. It's this gorgeous blend of antiquity and futurism, achieving strictly unbiased bit-perfect orientation for advanced 1-bit AI models. As the research points out, this completely changes our relationship with digital reality. We move from being a lossy observer, just throwing darts at a dartboard to guess a curve, to achieving true geometric lock-in. We finally possess undeniable, forensically accountable digital truth that can be perfectly traced and verified across millions of machines without fail. And beyond just securing AI from nasty hallucinations or preventing DeFi pools from suffering weird rounding exploits, this bit-perfect orientation unlocks absolutely staggering hardware efficiency. Because integer math is just so lightweight, the processing power required to run these operations absolutely plummets. Honestly, the drop-off is staggering. When we map the metabolic energy of legacy 16-bit floating point calculations against this new discrete integer geometry, it isn't just an iterative improvement, it is nothing short of a massive paradigm shift in how we consume power for compute. By eliminating the trig wall entirely and shifting all the math over to the surveyor, the architecture hits a hardware energy floor of an astonishing 0.05 picojoules per operation. This is a level of hyper-efficiency that simply was not possible when we were forcing processors to constantly grind through infinite decimals. To put that in perspective, that 0.05 picojoules represents a massive 74 times reduction in energy compared to standard legacy computing methods. By mathematically securing our exactness, we effectively liquidate our observer debt and create a highly sustainable digital ladder for storing and processing information. We are officially crossing a frontier here, folks. We're entering the age of the ALU surveyor, where we can build massive 1-bit AI models, highly complex smart contracts, and entire digital ecosystems on the unyielding certainty of flawless logic gates. The hardware is finally, truly ready to tell us the exact truth. Which leaves us with this final provocative thought to ponder today. Now that we've bridged this massive gap, completely shattered the trig wall, and secured bit-perfect execution straight down to the physical silicon, what magnificent, undeniable reality will you choose to orchestrate today? Thank you so much for joining me on this explainer. Keep exploring, and I'll see you next time.